Heating up! Hey, how's it going? Thorne here. So we're going to talk about the states of matter, and there are 3 states of matter that we're really concerned about in physics. Of course, you know, some might say there's a 4th state of matter like plasma, but we're not going to get into that right now. We're concentrating on the solid, liquid, and gas. Okay, so we have 3 beakers. All of them are empty, or are they? Okay, we'll get to that in a second. But I just basically want to show you quickly the differences between solid, liquid, and gas to give you some sort of visual here. So it might look like we're going to light something on fire here today, but we're actually not going to do that right now. But in science, we do light things on fire sometimes, and it is fun in a controlled setting and safely. So, got some solids here. I'm just going to put those solids in. All right. Okay, some nice Lego block pieces. All right, so the thing about solids will hold their shape. Solids will not change their volume. This is why there's still a little bit of space in between these solids in this container. A solid will not adjust its shape or its volume to fill the container. All right, that's what solids do. Next, another beaker. We're going to take some salty water, all right, in this giant Florence flask. Ignore that. And we're going to pour the... All right. Okay, next we're going to talk about liquids. So here we have, again, another beaker. Nothing in it right now. And I'm going to take this giant Florence flask of salty water. All right, and we're just going to pour that in there like you would with your orange juice in the morning. Except I wouldn't want to drink salty water in the morning. It'd be kind of gross. And there we go. Now, the thing about liquids, you might think nothing spectacular, but it's different than the solid, okay? Because that liquid changed its shape to fill that container, all right? Just like it had a shape in this Florence flask, all right? Kind of this cylindrical shape. Well, now it's got more of a, okay, it's a smaller shape here. It's another cylinder, but it's shaped like this container. So liquids can do that. They adapt to the shape of their container. But again, like the solid, it's not going to change its volume here. As long as I keep the temperature stable in this liquid, it's going to stay the same volume in this container. All right, so that's liquid. All right, lastly, we have another beaker with absolutely nothing in it, right? Wrong! There's air in it. Okay, I don't want to do that. Lastly, we've got this beaker here with nothing in it, right? Wrong. There's air in it. Oh yeah, okay, all right. Being smarty pants now. So there's air in this container because it is obviously coming in from the room. There's air in this room, otherwise I wouldn't be able to breathe. And the thing about gases, like air, is that they easily change shape to their container, much like the liquid, but on top of that, they change their volume quite easily as well. So air is easy to compress and it expands, and you can do this by a couple of things. One, you can squeeze stuff into it. Okay, let's think about a fire extinguisher. All right, cool, a fire extinguisher. Where'd this come from? So fire extinguishers are compressed gases. They contain a lot of other stuff, okay, like this one here, an ABC fire extinguisher has chemicals in it. But the propellant, the gas that's in it, that's squeezed in there and it's under pressure, which is why when we release the pressure, it wants to expand out into the room. So the gas that's in it changes its volume really quickly from being in this little space to a really big space, okay? So gases will expand, they'll change their volume pretty easily and change shape. And that's really quite simply a quick show of the differences between solid, liquid, and gas. It was overzealous. Was it overzealous? Okay.